the things that people are used to doing, but actually in the live robot.
Yeah, it's the same environment, same experience you get with JavaONE on your desktop or your laptop or on your Sunspot. And it's the same environment experience.
I think it's going to make next year's competition is going to be interesting because the kids in the organization will be kind of learning what it means.
What you're actually seeing up on the big screen is obviously a world map, and showing some of the ground stations for a network I just made up for the JavaONE. So you see different colors for different ground stations, the different colors depicting the different states of the ground stations. Green is okay, so everything's fine. Yellow, there's some small problems, so it's kind of warning and such stuff. So you can just go to the map, select one of those, and just start to drill into the station, and have here a view of how the wiring inside the station really is done. So you see here some devices, how they are connected, and station. And there you get all this monitoring and control stuff.
Right.
So you can just, with a few clicks, drill down on a component level, so you really get one device, and you can just get there and get all the information that is available for this device.
That essentially has a hash table of a lot of images.
Yeah, so right now we have about 150 million images. We're indexing at a rate of about 400 images per second, so roughly 1 billion a month. We're a young company, we've been around for less than a year. So yeah, the index that we have is pretty substantial.
Right, and the front end that you've built that looks to me like an FX app.
That's correct. This is, as a matter of fact, this is a JavaFX app that we've developed. I'm proud to say that, again, it's a very talented team put this together in a week. So what we're looking at here, this is an actual biopsy slide, prostate biopsy time.
Right, so you just searched many millions of biopsies to find similar features.
90,000 images in this case in 0.3 seconds.
Yeah, and so what you end up with is images that are kind of similar with patient outcomes, patient histories.
Yeah, so we can click on the patient outcome here and look at the diagnosis. And in this case, this was cancer, unfortunately.
Yeah, that's pretty cool, and I suspect that there are more than a few people in this room.
At really high speeds around a rally course, using a GPS-defined rally course, and it's going to go fast.
So this is the Urban Grand Challenge with the wheels unstuck from the pavement.
Exactly.
The whole time.
Exactly. So on the next slide, we have the teams that are participating in this. The Volkswagen Engineering Research Lab here in Palo Alto, they're actually building and instrumenting the Audi. Of course, it's drive-by-wire, so we're kind of injecting ourselves into the drive-by-wire system. And that's part of the deal, as well as what they're doing is developing the safety strategy. We'll talk a little bit more about that. Remember, this car is going to be going 160 kph, so without a driver. The platform that they're using, they don't trust. That's why they came to us.
Right. Right. I mean, one of the interesting things about Java is all the stuff about fault handling, fault containment, fault isolation that is just pretty unique. I mean, it's something that Java developers don't usually think about, but when things go wrong, they don't go spectacularly wrong. Right, we can recover.
So this is typically where we end up running our vehicles as a large skid pad with lots of runoff room. We've got the prototype vehicle. Right now we're working on taking all of this code and beginning to run it on our Audi TTS.
Right, so in this platform the code's pretty fragile, has timing issues.
Oh yeah.
Yeah, yada yada.
Yeah, if it goes over, if it runs a little bit slow on one side, the whole vehicle will freeze and they have to step on the brakes and try to wrestle it back into control.
Right.
Not so good.
Right, so your vision.
She looks so beautiful
part will help you also just read it up on some patterns.
Right, this is Jonathan Goodwin, the engineer who actually put together the mechanical parts. Paul Perrone, who the guy who plays with electrons, and Larry Johnson, who's Neil's producer. So, talk to us about the link bolt. What goes on here, and why did Neil want to do this?
Well, about a year and a half ago, Neil Young come to me and he's like, Jonathan, he says, what do you think about building an environmentally friendly drivetrain in a '59 Lincoln? I thought to myself, I'm like, this guy been drinking or what? This car's 6,000 pounds. You know, how are you going to make this environmentally friendly? So I started thinking about what is the most fuel efficient vehicle in the world of motor transportation, and essentially it's a train. So I come up with a concept that I call a series hybrid electric, and I'll show you how it works.
All right.
Underneath the hood, in this case, our propulsion system is actually located here in the back, and it's just essentially electric motors, 150 kilowatt, 500 foot-pounds of torque. And that runs on a set of lithium-ion batteries, which are located back here in the backside. So back here we have the 31 kilowatt battery pack that supplies the power for the electric motors. But we wanted to go a little bit further than just making a plug-in, so we wanted to give the car kind of a long-range capability. So 75 kilowatts of electricity, which is about 3 times as much as what this car consumes running down the road. So we can actually repower the battery pack very quickly and do that during the drive cycle of the vehicle. But with all this, these mechanisms and everything that are going on, we had to come up with a way to be able to control that. So we brought Paul in, and Paul brought in Java to be able to control that, and I'll let Paul explain how that control system works.
Yeah, well, essentially what started out as a sensor telemetry project kind of grew from there. So now we have lots of Java ghosts in the machine. Basically, we've strewn throughout the car multiple sensors gathering data about, for example, we've got a sensor to detect the battery voltage for each battery cell. There are about 100 batteries in the car. We're detecting things like temperatures, fuel levels, and we're kind of collecting all this data, including GPS, roll pitch yaw. We're collecting all this data and pushing it to the web so that folks can kind of follow along with Neil as he drives across country and kind of see how the car is performing. We're also pushing that data to a user interface, a touch screen in the car. It's a swing-based user interface so that they can also see what the car is doing and actually start to control parts of the car. And we're also doing that automatically now too. We've taken some of the sensor data and, for example, detecting when the batteries get too low, we go through a process by which we turn on the generator. When the batteries come up to a stable level, we turn off the generator. And we also do other things that these kinds of vehicles need to do. For example, when they let go of the throttle, the car actually starts to slow down. The folks behind don't know what's going on, so we detect the regenerative braking level and turn on the brake lights. And we're even also controlling the stock speedometer using Java, just through some conversion process. We're detecting the speed and controlling this old school analog speedometer inside the car.
So we're building this thing. I mean, you guys. I know that Neil wanted to keep the look and feel of the '59 Continental, which seemed somewhat absurd. I think everybody else would have gone for the Jetsons look.
Yeah.
But then it wouldn't be Neil. And you guys did a really good job of integrating into this and ending up with something that's really efficient. So